What is monkey patching? I am trying to understand what is monkey patching or a monkey patch. Is that something like methods of operators overloading or delegating? Does it have anything common with these things?
No, it's not like any of those things. It's simply the dynamic replacement of attributes at runtime. For instance, consider a class that has a method get_data. This method does an external lookup on a database or web API, for example, and various other methods in the class call it. However, in a unit test, you don't want to depend on the external data source, so you dynamically replace the get_data method with a stub that returns some fixed data. Because Python classes are mutable, and methods are just attributes of the class, you can do this as much as you like, and, in fact, you can even replace classes and functions in a module in exactly the same way. But, as a commenter pointed out, use caution when monkey patching. If anything else besides your test logic calls get_data as well, it will also call your monkey patched replacement rather than the original, which can be good or bad. Just beware. If some variable or attribute exists that also points to the get_data function by the time you replace it, this alias will not change its meaning and will continue to point to the original get_data. Why? Python just rebinds the name get_data in your class to some other function object. Other name bindings are not impacted at all.
A monkey patch is a piece of Python code which extends or modifies other code at runtime, typically at startup. A simple example looks like this. Source: monkey patch page on ZopeWiki.
What is a monkey patch? Simply put, monkey patching is making changes to a module or class while the program is running. Example and usage. There's an example of monkey patching in the pandas documentation. To break this down, first we import our module. Next we create a method definition, which exists unbound and free outside the scope of any class definitions. Since the distinction is fairly meaningless between a function and an unbound method, Python 3 does away with the unbound method. Next we simply attach that method to the class we want to use it on. And then we can use the method on an instance of the class, and delete the method when we're done. Caveat for name mangling. If you're using name mangling, prefixing attributes with a double underscore, which alters the name, and which I don't recommend, you'll have to name mangle manually if you do this. Since I don't recommend name mangling, I will not demonstrate it here. Testing example. How can we use this knowledge, for example, in testing? Say we need to simulate a data retrieval call to an outside data source that results in an error, because we want to ensure correct behavior in such a case. We can monkey patch the data structure to ensure this behavior. So using a similar method name as suggested by Daniel Roseman. And when we test it for behavior that relies on this method raising an error, if correctly implemented, we'll get that behavior in the test results. Just doing the above will alter the structure object for the life of the process, so you'll want to use setups and teardowns in your unitists to avoid doing that, e.g. While the above is fine, it would probably be a better idea to use the mock library to patch the code. Mock's patch decorator would be less error-prone than doing the above, which would require more lines of code and thus more opportunities to introduce errors. I have yet to review the code in mock, but I imagine it uses monkey patching in a similar way.
According to Wikipedia. In Python, the term monkey patch only refers to dynamic modifications of a class or module at runtime, motivated by the intent to patch existing third-party code as a workaround to a bug or feature which does not act as you desire.
First, monkey patching is an evil hack, in my opinion. It is often used to replace a method on the module or class level with a custom implementation. The most common use case is adding a workaround for a bug in a module or class when you can't replace the original code. In this case, you replace the wrong code through monkey patching with an implementation inside your own modular package.
If you want to